Hello, everybody. Time for yet another application of the definite integral. And this one is the area between two curves. Now, I guess, is this new? Not really. I guess if you really think about it. The reason is because I have made earlier videos about how to find the area under a curve, and this idea of finding the area between two curves is just an extension of that. Nonetheless, I want to make a video to specifically address it. All right? Okay, so that's what I'm going to do. So let's talk about, in part one, the concept of what I want to do and how you set things up. So here you see a graph, okay? And there are two curves on it. This one's called f of x, this one's called g of x. And then I have 2 points marked on the x-axis, point A and point B. And what we're looking at in the picture is the area between the curves from point A to point B. It's shaded in red right there, okay? If you want to know how big that is, which is all that area would tell us, it tells us the physical size of this region. It can be calculated as this definite integral, the definite integral from point A to point B of f of x minus g of x dx. Now notice that when I subtract in my integral f of x minus g of x, there is an order there. Okay, it's f first, then minus, and then g second. And we do it that way whenever the curve f is above the curve g, okay? Or if f of x is more than g of x, the same thing, same idea. You know, the y coordinate for this point is a bigger number than the y coordinate for this point on the curve under it, all right? So we subtract in the order of the upper curve minus the lower curve. So like up minus down, all right? So that's how we set things up, and that's how we will measure it. Now, as far as evaluating the definite integral, you do that the same way that we always have done this. I've only shown you one way to evaluate a definite integral, and that's that you find the antiderivative of whatever this formula, whatever's in here, okay? Like, which would vary from one problem to the other, but you find the antiderivative of that, you plug in B, you plug in A, and you subtract. Okay, so that's not going to change. All right, how we evaluate it once we get it set up is not going to change from other things that we've done. All right, so that's part one, concept in the setup. Now, part two will be to do this example here. Okay, all right, so I actually took this one from the assignment that I created on my math lab. And on the assignment, there's no picture given, all right? It just says calculate the area between these curves. X is 2, x is negative 2, y is 5x, and y is x squared minus 6, okay? No picture is given. Like, it's up to us to figure out what that picture is. Do we need a picture? Well, yeah, because look, you've got to figure out which curve is above the other one, okay? Because you're supposed to take the upper curve minus the lower curve. Another reason is, it doesn't really say find the area between the curves from point A to point B. I guess we'll have to figure out what point A and point B are, all right? So here is a sketch that I've drawn of this situation, okay? X is 2 is a vertical line that goes through 2 on the x-axis. That's right here. X is negative 2 is also a vertical line, but it goes through negative 2 on the x-axis. Okay? Y is 5x is a straight line that goes through the origin like this. Okay? And y is x squared minus 6 is this parabola like so. Now this graph is not to scale, but it is still accurate for our needs to set up our problem. Now, what I notice about this is that this line and this curve cross over each other. So if I look at all the space between all of these, between this, between this, between this, between this, that's like contained all of them, all right? This region over here is outside of these vertical lines, so it doesn't count. What you see shaded in red is the area contained by all of them. All right. Now, what I notice is that for some part of it right here, which I'll call region A, the curve, the parabola is above the line. But then they cross over at this point right here. And then for the rest of it, the line is above the parabola. All right. So I would need that amount of detail in order to set things up. Okay. Now, all right. How can you do that? Here I graphed this one. I actually solved for this point of intersection right here. So I'll put a note there, the point of intersection, just in case you might need to solve for that yourself. I take the line and I set it equal to the curve. Okay. And I get like so. Okay. And I will get that they intersect at -1 and also at 6. Yes, 6. Okay. So this other point of intersection is at 6, but it's outside of the other graphs that they gave us. Okay. So that's how I figured out where that is. Now, so all right, now you'll have to get this somehow. You'll have to get this picture somehow because it is necessary, even if it's not nice and neat like mine, it is necessary to figure out the setup. Okay. So here's what you can do. So all right, here's one that I use sometimes if I need to graph something. It's at Desmos. So you go to desmos.com and a graphing calculator is one of the options. Okay. So here I put in everything. Here's x is -2, x is 2, y is 5x, y is x squared minus 6. And it plots it all. And like what I have graphed, not to scale, like this is to scale, is this region right here. Okay. And then this region right here. Okay. That's what I have drawn and shaded over on my paper. All right. And this is even color coded so that you can see what's what. All right, and see that right there, that point where they intersect each other and cross over, okay? Then that is at -1, which we can also see on the graph. So I get that same information. Okay, now I've divided the area between those two curves into region A and region B. I will measure the areas of those regions separately because on one, the parabola is above the line, and in the other, the line is above the parabola. So here we go. The area of region A right here is going to be the definite integral from, so I want to go from right here, which is that vertical line at -2. So I want to go from -2 over to this point where they cross over. So from -2 to 1. Those bounds, you see the lower and the upper bound on this definite integral, mark off region A. And then what order do I subtract? The parabola is above the line. Okay, so I take x squared minus 6. Okay, subtract 5x. Now, notice that I don't have any work to evaluate this integral. And that's because I've, in other videos, showed you how to do that. And I thought I'd save a little bit of time on this video. But also, I wanted to mention that in our class, the curriculum is such that you will learn how to evaluate these integrals by yourself without a calculator doing it for you. And yes, I will ask you to submit some work where sometimes that's what you do. You show me all the steps. But I'm also not opposed to you using tools to do that for you. Calculators, software, whatever you want. So I went to Wolfram Alpha to show you something that I like. I like this because it tells you a lot of details about what you're doing. You might see that it tells you more than you want to know, but here goes. Let's say that I want to evaluate this definite integral from -2 to -1 x squared minus 6 minus 5x. Then I can type literally that in. The definite integral of x squared, x squared minus 6 minus 5x from -2 to -1. Okay. All right, press enter and it will tell me, very fast what that is. It's 23 over 6. Okay. All right, so notice I got 23 over 6 there. So here I used a calculator to do that for me. I wanted to make it easy. All right, you can do that too. I'm just going to ask that on the test for the questions that you have to submit work, that you follow the instructions. If the instructions say to work the problem out step by step, then you do that. If the instructions say it's okay to use a calculator to do it for you, then you can do it that way. Just follow the instructions. You can't go wrong following the instructions. Now, so that's how big region A is, 23 over 6. Region B, well, okay, so I'm looking at that right here, and that would be from -1 over to 2. Okay, so notice my bounds are -1 over to 2. And then I see that the line is above the parabola. So I need to take 5x and subtract x squared minus 6. So that's what you have here. But be careful, because if I take 5x, the curve that's on top, and then I subtract x squared minus 6, the curve that's under it, that subtraction must apply to that entire formula. So I put a note here that this is what I want to do, but I need to remember to distribute this negative as I work it out, or I could type exactly this with that parentheses in there in a calculator and have it do it for me, whatever. But you've got to take note of how this negative applies. So I put that happens to make it this way. It'll make it 5x minus x squared plus 6. Okay, and that turns out to be 45 over 2. I did that one again with Wolfram Alpha to make things easy, but also because I wanted to show you. All right, so I know how big region A is, and I know how big region B is. So for me to tell you the total area contained between all 4 of these graphs, one here, one up, one down, all that shaded in red, okay, would be 23 over 6 plus 45 over 2. You add together, you get 79 over 3. All right. Now, why give it as 79 over 3? Can I take 79 and divide by 3 with my calculator and give you a decimal? Sure, you can do that, but I did take this one from my math lab, and I wanted to always point out that you follow the instructions and give your answer according to those, whatever they are on my math lab. Here it says, for this question that I just did for you, type an integer is a whole number, positive or negative whole number, or an improper fraction. Okay, well, 79 over 3 is an improper fraction. It doesn't say to round your answer or anything like that. All right. Okay, so that's how we find the area between the curves. We'll probably need some kind of a graph. We may also need to find out where the 2 graphs intersect. Okay, but once we have all those numbers, it's just definite integrals from there, something that hopefully we've already learned how to do.